given the equation f of x equals log base 2 of x, and we have several questions to answer, and if any of the answers come out where they do not exist, we are to write D and E. So to explain many of these questions, I'm going to refer to the graph of y equals log base 2 of x. But I want to show you that as long as b is bigger than 1, we know something about the graph of a logarithm, and many of the answers to these questions will follow based on that. So if you let me switch to a website called Desmos.com, here what you see is the graph of log base 2 of x, and you may notice that when I switch to larger bases, that a lot of the features of a logarithm stay the same. In fact, what you'll see is I change from base 2 to base 10. You will always have a vertical asymptote of x equals 0, meaning the graph will actually never cross or even touch the y-axis. And notice that the point 1 comma 0 here will remain the same regardless of the base. So increasing the base of a logarithm from base 2 to say base 10 makes the logarithm grow slower. I'll try to do this as slow as possible. And you notice as b gets bigger, the logarithm grows slower. But notice the point 1 comma 0 does not change. In fact, let me kind of go back and forth and show you for different values of b, as long as b is bigger than 1, it always has a vertical asymptote of x equals 0 and always has a horizontal intercept of 1 comma 0. As long as b is bigger than 1, they'll all have the following features. They will all have a vertical asymptote at x equals 0. So a vertical asymptote basically means that the graph goes vertical, and we are to tell where that happens at. It happens at x equals 0 for all logarithms of base b bigger than 1. So where it says to determine the equation of the vertical asymptote, that would be x equals 0. Please remind yourself that this is the equation for a vertical line. It's not just an x value. This is the equation that if you graph that equation, you'd get a vertical line through 0. Now, to answer the other questions, what is the vertical intercept? Well, I just said that the logarithms have a vertical asymptote of x equals 0. In a different class, you may learn how to shift the graph left and right, and that would change that. But basically, if you have something of the form log base b of x, and b is bigger than 1, then the graph of that is going to have a vertical asymptote at x equals 0, and the vertical intercept will not exist. So I'm going to write the D and E here for it does not exist. The graph does not cross the vertical axis. Now, the horizontal intercept of a logarithm is always 1, 0. Again, this can change in future classes if they teach you how to shift graphs left and right. But if you just graph anything of this form here, log base b of x, where b is bigger than 1, you will have a horizontal intercept of 1 comma 0. And that's actually pretty easy to show why. A horizontal intercept is where the y value here is 0. So if I didn't tell you the answer, what you would do is you'd say, okay, I need to find x, question mark, so that the output becomes 0. So algebraically, you'd be taking the output variable f of x and replacing it with 0 and solving. And to solve that, what you would do is, one way, would be to change to exponential form. So to change this from log form to exponential form, what you would do is copy the base of 2, and then you'd say that 2 gets raised to the 0 power to give you x. So this is just switching from log form to exponential. I get that this base of 2 raised to the exponent of 0 gives me x. And if you wanted on your calculator, you could do this, but numbers to the 0 power always give you 1. So I get that x is equal to 1. Now there is one exception to that. 0 to the 0 is undefined, but all of the numbers of the 0 power give you 1, so that would give you an x value of 1. The logarithms of this form have horizontal intercepts of 1 comma 0. They do not have vertical intercepts. They always have a vertical asymptote of x equals 0. And to find the domain and the range, again, as long as we're in this form, all of the answers are the same. The graph never actually hit the y-axis. That means that the x values lie always to the right of the y-axis, meaning the x values are always positive. So my domain in inequality notation would simply be that the x values are strictly greater than 0. They can't be 0 because there's no vertical intercept, but anything greater than 0 is fine for the domain. And then in interval notation, let me write int for interval notation, that would look like 0 would be the furthest to the left that it goes, but not including 0, so put a parenthesis, comma, and the graph goes to the right forever, so you can plug in any x values, I should say, and it would take on all values to the right of 0, so that goes to infinity, and since you never reach infinity, we always put a parenthesis there. And the range for all logarithms of this form go down forever, and sometimes they look like they level off. Sometimes they look like they have a horizontal asymptote, but they don't. If I wanted any y value that you asked for, I could find an x value big enough that would reach that high. So they're not limited in height. There's no horizontal asymptote. So the range basically is all real numbers. The graph goes down forever, and the graph goes up forever. So in inequality notation, my range here would be that my y values are bigger than negative infinity, and at the same time y is less than infinity is one way to write it. The other way to write it is to combine that into a compound inequality. Let me show you what that looks like. You would write negative infinity is less than y, which is less than infinity. And this means the same thing. It means that y is less than infinity, and at the same time y is bigger than negative infinity. That's just a fancy way of writing all real numbers. And let me write the interval notation here. The interval notation would be same thing, negative infinity. Because we're doing the range here, it's just assumed that we're talking about y values. You need not write the letter y. And you write the infinity, and since you can't reach infinity or negative infinity, we always put parentheses there as to not include them. Let me box my answers in red. My domain is this in inequality and interval notation, and my range, since I'm running out of room here, my range would be all of this, both in inequality notation and interval notation. So I answered this one, I answered this one, this one, and this one, and this one. What's left is I need to answer what f of 25 is and determine x when f of x is 3. So now that I cleared the board, I want to first find f of 25. To do that, I will copy the original function f of x, which is equal to log base 2 of x. And the idea is we are to replace x with 25. So doing so would give me that my output is log base 2 of 25. I have no idea what that is. I can guesstimate what it is. After all, what this means is 2 gets raised to some power to give you 25. So I can guesstimate, because 2 to the 5th is 32. That would be too big, so the answer must not be as big as 5. And I know that 2 to the 4th is 16, and 16 is too small, right? We're trying to get out 25. I know my answer is between 4 and 5, but I'm going to need a calculator to help me out to get a more accurate answer. So on my calculator, I'm actually going to have to use the change of base formula because my calculator doesn't do base 2. And the change of base formula basically says that you take the log of 25 and you divide by the log of 2. Now it doesn't look like we changed the base because I'm still using the 2 there, but by not writing the base, I mean that we're using base 10. So if you let me load my emulator, I can do the calculation by simply pressing log 25, and since the calculator is not writing the base, I'm assuming this is base 10, and it is, divided by the log of 2. And I'll go to decimal approximation, and as I said before, it seems to me the answer should be bigger than 4 but smaller than 5. And there it is, it's about 4.64. So I'm going to say f of 25 is this. This is the exact answer. Or if you want, that's approximately about 4.64. So either answer you prefer. Log base 2 of 25 would be the exact answer. The approximate answer would be f of 25 is approximately 4.64. The last problem is determine x when f of x is equal to 3. So I'm going to start much like I did the one just before that, except this time they're not giving me the input. In fact, they're telling me to find the input, find x, determine x, so that f of x is equal to 3. So if they want f of x to be 3, I'll do just that. Where I see the notation f of x, that's my output variable, I will replace it with the number 3. This one's going to be very simple to solve. As soon as you change from log form to exponential form, you would say that 2 raised to the 3rd power gives you x. So writing down what I just said, it would be the base of 2, gets raised to a power of 3, and the result is x. So this is called changing from log form to exponential form, and basically solved for x, because I have x equals, and 2 cubed is 8. So x equals 8 is the solution to that question.